Okay. Well, this is coming from 1.6, which is an inequality section, which really shouldn't impact our math at all, but I'm just telling you where the problem's coming from. As I read through this word problem, I'm getting two different pieces. I'm getting an investment of $12,000, so a total investment. I'm going to grab my pen here. So I have a total investment of $12,000. That's going to be invested in two different parts. And so I'm going to use one color of ink for one part and one color of ink for the second part. So I'm going to use purple for my 4 interest rate. So I'm going to kind of have part A, and that'll be at a rate of 0.04. Then I'm going to have kind of investment B, and that's going to be at a rate of 0.06. Now, I want to do these interest rates, and I'm talking about interest per year. And so I'm going to let my time equal years for both. And so this is kind of back into the green total thing. My time equals 1 year, because that's the same for both. Now, my total investment, that doesn't mean that I have a $12,000 principal in 4% and a $12,000 principal in 6%. This type of problem is called a mixture problem because I'm mixing two different things together. And so what I really have is I have two different principles mixed together to give me this $12,000. I have my principal for part A plus my principal for part B equals the $12,000. Now, if I think about this in terms of simple interest, well, my simple interest rate formula was interest equals principal times rate times time. So for the part A investment, or the investment A, my interest A, so the interest earned in this investment, is going to be the principal from part A times my rate from part A, but that's 0.04, so I don't need to put in an unknown there. And then my time was 1 year, so I'm just going to leave it alone because it's like multiplied by 1 is the multiplicative identity. It doesn't change anything. So I don't need to write times 1 because times 1 doesn't change it. Well, let's write down the same equation for my B investment. So my B investment, that's going to be my principal B times 0.06. Okay, so let's clean that up just a little bit. I've got IA equals 0.04 times PA, and then I have IB equals 0.06 times PB. Now, how am I going to put all of this together to find out what's the most that she can invest at 4% and still be guaranteed at least $650 of interest per year? Well, that sounds like this last bit is setting up an inequality. What it sounds like is that the two interests summed together must be at least $650, right? And so what I really have here is that IA plus IB must be at least, and by at least, I'm going to say that means greater than or equal to, because at least would mean that the minimum value would be $650. Well, I have an equation for IA, and I have an equation for IB, so let's go ahead and put those in. Let's take my IA value here and put it in for IA. Let's take my IB value here and put it in for IB. Well, what's that going to do? That's going to give me 0.04 principal from A plus 0.06 principal from B is greater than or equal to 650. Now that's still two unknowns in one relationship, which is not good enough. I don't have enough equations until I look way back up here and say that's another equation, another relationship with the same two unknowns. And so now I have two relationships and two unknowns, and now I have enough. I have enough to do my work. And so I'm going to call that equation 1. I'm going to call that equation 2. So I'm going to come over here with equation 1, and I'm going to say that PA plus PB equals 12,000. And I can solve that for PA. PA equals 12, not 10, 12,000 minus PB. Now the reason I do that is because I want to substitute into equation 2 and get rid of the PAs in equation 2 so that all I'm left with is PBs in equation 2, and then I can actually find out that value. Oh. Is that really what I want? No, because I've been asked about what's the most you can invest at 4%, and PB is at 6%. So let's let that inform us a little bit as to what we solve for here. What do I actually want? I actually want to replace PB in my equation 2 because I've actually been asked about how much should she invest at 4%. What's the most she can invest at 4% and still have that 650. All right, so now that I've got that cleared up, I'm going to take this value and I'm going to put it in place. Let's not take up all of our white space. Put it in place of PB, and then finish that, putting that inequality together. 0.04 PA plus 0.06, but instead of PB, I'm going to write down 12,000 minus PA, and that must be greater than or equal to 650. We write smaller and smaller and smaller as we get closer to the edge, and sometimes we still can't make it. So I'm going to write the 650 a little bit low so we have a little bit more space. Okay. 0.04 PA. Can't do anything with that yet. 0.04 PA. But we can start to do stuff with this. So my 0.06 times my 12,000 should give me a number. Yes, gives me a much smaller number, which makes me happy because it should be a much smaller number. 720 minus my 0.06 PA greater than or equal to 650. Well, I want to get all my PAs on one side and all my numbers on the other side. And so when I combine those two values for PA, I'm going to get minus 0.02 PA, right? 0.04 minus 0.06 leaves me with negative 0.02. Now, to get rid of the 720, I'm going to have to do minus 720 and then minus 720. What's that going to leave me with? So I got greater than or equal to minus 70. And just because, let's type that in, minus 650 minus 720 gives me minus 70. Hey, I can do math. It's nice to confirm that fact sometimes, though. All right, so with this in front of me, I, of course, want to divide both sides of this equation by my negative 0.02 and divide my negative 70 by negative 0.02. But then I got to remember something about working with inequalities. I got to remember that any time I multiply or divide both sides by a negative 1, I have to change the direction of that inequality symbol. It has to do with whether or not we're scaling things around the 0 or whether or not we're shifting things left or right along with the 0. Adding or subtracting shifts things left or right. Multiplying or dividing scales things. But if I take two numbers on my number line, and I've got a 0 here, I've got a number 1 and number 2, if I scale those two numbers by multiplying them by a large number, well, it's going to give me grief here. Basically, this number would move that far down, and this number would move a scaled value down, and it wouldn't look as far, right? But if I multiply it by a negative number, then they're going to flip over the axis. And all of a sudden, the one that was smaller is actually larger than the other one. And so that's why anytime we multiply or divide both sides of an inequality by a negative number, we have to change the direction of that inequality. And I always like to put like a little F there or something as I'm writing this, just to remind me that when I'm writing the next line of my equation down, that I need to change the direction or flip the direction of that inequality. All right, so now I have PA. But instead of greater than or equal to, it's less than or equal to. And then 70 divided by 0.02, the negative over negative becomes a positive. And so I have 70 divided by 0.02, and I get $3,500. And so what we're saying is that of the $12,000 that this person wants to invest, the most of it that they can invest at the smaller interest rate, the more conservative investment, to get the amount of interest that they need per year is this $3,500. I hope that helps us put together these kind of mixture problems.